Hello everyone. So this is what the little part of electromagnetic waves. So see here, this is momentum and radiation pressure. Okay. So electromagnetic waves have linear momentum as well as energy. Yes. When electromagnetic waves strike a surface, pressure is exerted on it called radiation pressure. Okay. What is that? Called radiation pressure. Now, these electromagnetic waves are incident on a surface and the total energy transferred to the surface in a time t is u. Then the magnitude of momentum P is equal to u by c, where this u is energy, c is what? Velocity of light. Now you see here how we are getting this. E is equal to mc square. Yes. And this mc square I can write as a mc into c. Yes. Okay. And this mc is equal to E by c. So if I will substitute here, what I am getting here, E by c. So P is equal to E by c. Okay, P is equal to what? E by c, because this mc is there. No, this mc is nothing but mv. Mv means what? Momentum, and that's why this P is equal to E by c, and that's why you are getting here P is equal to U by c when there is a total absorption. Next one. When radiation incident on a surface is entirely reflected back along its original path, magnitude of momentum delivered to the surface, that is equal to 2u by c. So it is same like going and reflecting back with the same velocity, then you are getting 2 times p, we can say, that is mv minus mv, then what you will get, right? 2 mv, that is 2 times p, and that's why you are getting here 2 times of this p, and therefore 2 into u by c. Next one. When the radiation incident on a surface, that is perfect absorber, radiant on pressure, then pressure, radiation pressure we can say, this is radiation pressure, F by A. So this 1 by I am taking outside, and this F at the place of this F from the Newton's second law, dP by dt. We know this F is equal to dP by dt. So now this ddt here, and P value already we have U by C. You substitute here, and then you are getting du by dt, and this C also outside, 1 by AC du by dt. Now this du by A dt is nothing but the Poynting vector, and that's why I am substituting here as a yes. Which part? This complete part. This part is what? Poynting vector, and this C as it is, and that's why you are getting radiation pressure is equal to S by C. Okay. Next one. If the surface is perfect reflector, then radiation pressure is equal to, this is only PR, radiation pressure is what here? 2S by C. Okay, if it is a perfect reflector. Understand? So you can note down this all. Note down. Let's move ahead. Next topic is electromagnetic spectrum. What is this electromagnetic spectrum? See, it is the array obtained on arranging all the electromagnetic waves in an order on the basis of their wavelength. It is called electromagnetic spectrum. Okay. So these waves are gamma rays, X-rays, ultraviolet rays, visible light, infrared waves, microwaves, and radio waves. You can see here in the diagram below. This is gamma rays. This side all the frequencies we have, and here it is wavelength. X-rays, ultraviolet, visible, near infrared, okay, infrared, thermal, infrared, all these. So gamma rays wavelength frequency, X-rays wavelength frequency, ultraviolet wavelength frequency. Okay. So you can note down this. Below also some part is there. Okay. First you note down this part. You can draw this diagram. You have all wavelength range and frequency and wavelength range here. Okay. So you can draw this. Now let's move ahead, and whatever the spectrum we have drawn, we will see some details about that particular rays. First one is gamma rays. You can see here. They were discovered by Becquerel and Curie in 1896. Their wavelength is of order of 10 power minus 14 to 10 power minus 10 meter, which is there in above diagram. Okay. The main sources are the natural and artificial radioactive substances. The sources of this gamma rays is what? Natural and artificial radioactive substances. These rays affect the photographic plate, and these rays are mainly used in the treatment of cancer disease. So whatever we are learning now, they may ask you 2-mark question on this. Okay. So you have to read this theory carefully. Next one, that is X-rays. X-rays discovered by Röntgen in 1895. Their wavelength is of order of 10 power minus 12 meter to 10 power minus 18 meter. X-rays are produced when highly energetic cathode rays are stopped by a metal target of high melting point. So fast moving cathode rays, when we are stopping by a metal target, then X-rays will produce. They affect photographic plates, same like gamma rays, and can penetrate through the transparent materials also. They are mainly used in detecting the fracture of bones, hidden bullet, needle, costly material. It is inside the body, and also used in the study of crystal structure. This we know already. Okay, X-rays, fracture of bones particularly. Next one, ultraviolet rays. They are discovered by Ritter in 1801. Their wavelength is of order of 10 power minus 9 meter to 4 × 10 to the power minus 7 meter. In the radiations received from sun, major part is that of ultraviolet radiation. Its other sources are the electric discharge tube, carbon arc, etc. So sun is a source. Also, this electric discharge tube and carbon arc are the source of this ultraviolet rays. These radiations are mainly used in excitation of photoelectric effect and to kill the bacteria of many diseases. Okay, so this is what the use of ultraviolet rays. Next one, that is visible light. This was first read in 1666 by Newton. Radiations in the range of wavelength from 4 × 10 to the power minus 7 meter to 7 × 10 to the power minus 7 meter fall in the visible region. The wavelength of the light of violet color is the shortest. Okay, so first of all, you note down this remaining part, we will see ahead. Okay, so note down first. Let's move ahead. So it was in visible region, right? So we have seen that violet color has the least wavelength, whereas the red color is having the longest wavelength. Visual light is obtained from the glowing bodies while they are quite hot. The light obtained from the electric bulb, sodium lamp, fluorescent tube is the visible light. Okay. Next one, thermal or infrared waves. They were discovered by Herschel in 1800. Their wavelength is of the order of 7 × 10⁻⁷ to 10⁻³ meter. A body on being heated emits out the infrared waves. Okay. And these radiations have the maximum heating effect. Which radiations? Thermal or infrared waves. The glass absorbs these radiations. Therefore, for the study of these radiations, rock salt prism is used. Instead of glass prism, these waves are means which one we are using? Rock salt prism. Instead of glass prism, we are using to study the properties. These waves are mainly used for therapeutic purpose by the doctors because of their heating effect. Which one? This infrared waves. Next one, microwaves. They were discovered by Hertz in 1888. Their wavelength is in the range of nearly 10⁻⁴ meter to 1 meter. These waves are produced by the spark discharge or magnetron wall. They are detected by the crystal or semiconductor detector. These waves are used mainly in radar and long distance communication. This microwaves already we know. Microwaves are used in radar, spy. So this is what the answer is. Okay. So they may ask you question, microwaves are used in radar, spy. So you should know about this. Next one is radio waves. These waves were discovered by Marconi in 1895. Their wavelength is in the range of 0.1 meter to 10⁵ meter. They can be obtained by the flow of high frequency alternating current in an electric conductor. So this is what the source of this radio waves. These waves are detected by the tank circuit in a radio receiver or transmitter. Next one. Okay. So first note down this. Right? Note down first this thermal or infrared waves, microwaves, and radio waves. Next one, that is applications of electromagnetic waves. First one, radio and micro radiations are used in radio and TV communication system. Micro radiations are mainly used in radar and TV communication. Okay, this is first use. Next one, infrared radiations are used in greenhouse to keep the plant warm, in greenhouses to keep the plants warm, in revealing the secret writing on the ancient walls. These all are IP questions they are asking on these topics, whatever this theory is there. For looking through haze, fog and mist during wartime, as these radiations can pass through them. This is what use of infrared radiations. Next one, ultraviolet radiations are used in preserving the foodstuffs, in the detection of invisible writing, fog documents, fingerprints in forensic laboratory. And ultraviolet radiations are also used for knowing the structure of the molecules and arrangement of electrons in the external shells. So this is what use of ultraviolet radiations. Next one, X-rays, about the structure of atomic nuclei, in the study of crystal structure, in the fracture of bones, etc. This is what application. And next, last one, that is gamma rays, in treatment of cancer and tumors to produce nuclear reactions. So this is what use of this electromagnetic waves, on which they may ask you 2-mark question. So note down this all carefully. Okay. So this is what the end of this chapter. Okay. So we'll stop here. But don't forget to write the notes. Okay. Bye.